Okay, okay. So welcome to our AstroCafe session for the what I call 12th of August 2020. And by the way, this is the peak kemuncak, all right, of the Perseid Meteor Shower for the year 2020. All right. Some of you may not be aware, we are in a tropical island called Penang on the southwestern corner, just next to the beach, which is facing the Straits of Malacca. And opposite the strait will be a place called Sumatra in Indonesia. So this place is surrounded by coconut tree, our Lim Chun Kiat observatory in Balik Pulau, in a place called Pulau Betong. So now we are covering, we are here gathered, I think about 20 of us here tonight. Hopefully the sky will, now it's still cloudy, the sky will clear. Then we observe the meteor shower. So basically we will discuss a bit on this Perseid meteor shower in particular and meteor shower in general, right? So we know that the Perseid every year is a meteor shower that occurs between 17th of July and 24th of August. All right? You check with him, can hear? Okay, because he didn't respond. Usually I respond. And then the peak, of course, is tonight, the night of 12th and 13th of August, Wednesday night, Thursday morning. And then as I'm speaking now, there are thousands and thousands of astronomy enthusiasts on this planet observing it. Where? Europe, America, Africa, Asia, what do you call, Australia, New Zealand, South America, maybe on the North Pole and the South Pole. So we hope those guys who have clear weather, they should be able to see a lot. And for example, if you have a friend in Hawaii, call a friend in Hawaii now. New Zealand now, because now Perseid is appearing over Hawaii, New Zealand. All right, so they should be able to see now. For us, we have to wait because now the time is about 9 p.m. We have to wait about midnight and then 3 p.m. Why? Because right now, Balik Pulau, Malaysia, is still in the shadow of the meteor shower. What do you mean by the shadow? The thickness of the earth is blocking the meteor shower. So we want to be able to see the meteor shower is when we able to see the constellation of Perseid. So those of you who know the star chart here, all right, this is the star chart, all right. So somewhere over here, there's a constellation called the Perseid constellation of Perseid, and from there it will come, all right. So this will only Perseid will only rise in the northeast at about 12 midnight. So that means for Malaysia, we can see the Perseid meteor shower from 12 midnight, until when? If the weather is clear at 12 midnight, we should be able to see the whole meteor shower until sunrise. So Malaysia, sunrise is about 6:30 a.m. So from 12 to 6:30 a.m. is about 6.5 hours we can see. So in Malaysia and anywhere in the world, if the sky is clear tonight, so according to the International Meteor Organization, their predictions are very accurate. So on the website, you can check 110. What's that? The zenithal hourly rate, that means every hour under the best sky condition, no clouds, all right, and from vertically overhead, 110 Perseid meteor will appear every hour. So if we can observe that amount for 6 hours, it's about 700 meteors, for tonight. So we only hope for the weather, right? So that means we have to wait until about 12 midnight and after that, all right? But before that, if the sky is clear, so other than looking at the meteor shower, what we can see, Saturn, Jupiter, right? So a few nights ago, our member David, we were in Tech Dome Pixel Observatory. We saw Saturn and Jupiter, and sandwiched between Saturn and Jupiter is Pluto. So if you take an image, a wide-angle image of Saturn and Jupiter, somewhere in between the star field between Saturn and Jupiter, one of the point of light is not a star, is Pluto, right? So in between, before looking at the meteor shower, before 12 midnight, we can also look at Saturn and Jupiter and other objects. So you can see here, we have now a line here in Chungkiat Observatory. You saw the telescope? There you are. That's one telescope. And further there, there's another one behind there, another bigger telescope. All right. So with this telescope, we hope CK will come later on, and then we can observe. So CK and our pegawai Jabatan Mukti are having dinner now. All right. So the dinner is sponsored by Jabatan Mukti. We're so happy about that. All right. So it's an old story. So the Perseid meteor shower, I think, was first it was actually rediscovered in the 19th century. But when you check the records of the ancient Chinese astronomers, they've already been observing it, I think, in the 1st century BC. So that means the Perseid Meteor Shower has already been known to mankind for more than 2,000 years, but only recognized as a Perseid Meteor Shower in the 19th century. Right? So why is it called like that? Because they tie down the Perseid Meteor Shower to the comet. Right? So which comet? Comet Swift-Tuttle. Right? Somewhere in the 19th century, two American astronomers, Lewis Swift and Horace Parnell, Tuttle, they saw this comet and they discovered it. So the comet name was named after them, Comet Swift-Tuttle. And later on, they tied down to, hey, the direction of this meteor shower that comes seems to tie up with the orbit of Comet Swift-Tuttle. So the original material for this comet, from this meteor shower, came from Comet Swift-Tuttle. So it's confirmed, right? And then we know that the Comet Swift-Tuttle is a big lump of rock and ice. You know how big? 26 kilometers, half the length of Penang Island. So imagine you have an object, an asteroid, half the Penang Island smashed to the earth, gone. Then we become the dinosaurs. Remember, the dinosaurs disappeared in an astronomy event 65 million years ago. 10-kilometer size asteroid hit present-day Mexico and create a kind of global dust storm all over the world until more than 50% of the life form extinguished, mass extinction. All right. So this object, fortunately, the comet, Swift-Tuttle, 26 kilometers in diameter, has been followed for some time, and in the year 2126, will pass by the Earth. At one time, the astronomers thought it may crash to the Earth, but now they say that in the next 2,000 years, this comet Swift-Tuttle will not crash to the Earth. Right? And remember, we know that other than the moon, which is very close to the Earth, the next biggest object that can pass by the Earth is what? Comet Swift-Tuttle, 26 kilometers in diameter. Whereas asteroids are very small object passed by the Earth. All right, but this Comet Swift-Tuttle is big, 26 kilometers in diameter. Right. So that means we are now in the middle of the season for Perseid. Remember, starts on 17th of July, will end on the 24th of August. All right. So that means what? On the 17th of July, already the dust and particles from Comet Swift-Tuttle already entered the Earth's atmosphere to give the meteor shower. And if you look at it carefully, from the 17th of July to the 24th of August, the Earth is actually going through, orbiting around the sun, about 49 days. And remember, every second the Earth moves in the solar system 30 kilometers. So every second the Earth moves 30 kilometers, 49 days. The Earth will move 120 million kilometers. So that means the time when the meteors will strike the Earth, it's actually on a path which is 120 million kilometers long. That means 17th of August, it starts entering the Earth's atmosphere. And Earth will have moved a bit to a position the next night. So all the time the meteors are hitting. So the distance where the meteors are appearing on the Earth is on the orbit of the Earth, which is 120 million kilometers. No? So in other words, it's a tunnel of the dust particle. Remember, imagine that originally Comet Swift-Tuttle passed by the Earth once. So that means there are no dust particles following it. But this Comet Swift-Tuttle has a period of about 130 years. That means you come from the outer solar system, from the location of Pluto, you come closer to the sun, and orbit, and pass close to the sun, around the sun, just within the Earth's orbit around the sun, 150 million years, and then go out to the orbit of Pluto and come back to near the sun again. So this 133 years, right? So this as the over the 2,000 years that men have been following this comet, that means all the particles that follow the trail of this, the path of this Comet Swift-Tuttle, they will stretch around the whole orbit, not only stretch, but also expand as a tube. So it's a huge tube following the orbit of the comet around the sun. And this tube is what? The diameter of this comet Swift-Turtle tube is 120 million kilometers wide. All right, and how long is the tail of this debris following the comet? The whole orbit of the comet Swift-Turtle will have this debris following it. All right, that's it. So that's comet what they call Swift-Turtle. So now we are still waiting for the sky to clear. All right. So I'm sure many people in the world are what? Furiously checking their app. All right. The Sky Safari, the Sky Map, whatever, to see whether the sky conditions are good, clear or not. I think maybe some of the amateur astronomers in other countries, they may even do this. Let's put our telescope and our camera here, and suddenly the sky condition turn bad. They will drive another 200 kilometers somewhere else in the country to observe. But we cannot do that because we are fixed in Chungche's observatory. So we hope the sky will clear. All right. So anyone who want to ask question, you can put your comment in your YouTube. You can comment. We check when they ask question on YouTube just in case. All right. Now I'm sure everyone knows what it is. All right. Your mass. Do you know that this mass maybe have an intimate relation with the comet Swift-Turtle, Perseid Meteor Shower? How come? Right? It's like this. In 1974, two well-known British astronomers, all right, Sir Fred Hoyle from Cambridge University and Professor Chandra Vikramasinghe from University of Cardiff. So they made a fantastic proposal called the panspermia theory. Now remember, for many years, astronomers have been analyzing the meteorites that fell from the sky, all right? And analyzing the meteorites that come from the sky, they found in the meteorites, what did they find? Organic material, amino acids. Many of those molecules, organic molecules, are found in the meteorites. And with the telescope, they point at the comet tail. They let the light of the comet tail pass through a spectroscope. They see in the spectrum line of the tail of the comet got organic material, right? And they pointed the telescope on the moon of Saturn called Titan, got organic material. And then also they know that in the Milky Way galaxy, there are the famous planetary nebulae, the molecular clouds. So in the emission nebula, absorption nebula, and this reflection nebula is actually molecular clouds. And they are detected inside there with radio astronomy, with optical astronomy, infrared astronomy, a lot of more organic molecules. So basically, these two professors in 1974 proposed the panspermia theory that since there's so much organic material in space, so the earlier idea of the astronomers that life on Earth began by what is called the abiogenesis theory. Abiogenesis means the life on the Earth, when the Earth was young, 4.6 billion years ago, there was no life because there's no life. But later on, water collected and oceans formed, all right? And then the atmosphere formed in the Earth, the young Earth. Then from non-living life condition on the Earth, life came, all right? So the earlier theory was like this, is that now the Earth was very young, no life yet, got ocean, got atmosphere. Then you have lightning, you have UV light, you have the volcano on the Earth, a lot of violent phenomena occurring. Somewhere along the line, you can create organic molecule from all these processes, lightning, UV light, organic molecules form. And the organic molecules will seed the ocean, right? And later on, a very important part must come is then DNA is formed. The fantastic molecule that can replicate itself, can duplicate itself. So one DNA form, then it's a trigger to the life process on this planet, right? So you have the, what I call this, DNA form, and DNA will form more DNA and so on. And suddenly, further down the line, single cell organism is formed. The bacteria, the amoeba, the paramecium. So the bacteria is formed and single cell was formed. So life on the Earth, according to the earlier theory, formed from in the ocean, right? And then you have single cell, multiple cell, and then later on, the simple fishes were formed. So the first type of early life form on the Earth in ocean was the early fishes, right? We look different from the fishes now. And later on, the oceans were full of life, right? And later on, for one reason or another, life in the ocean went to the land. one of the scenarios like this, there's a type of fish that went to there's a kind of a flood that flood into the inner part of the land. So there is a lake there, all right? So the fishes were there, and later on the water receded. So there's a large pool of water trapped on land, and later on the fishes will develop and become amphibians. That means the fishes will have, due to evolution, right? Theory of evolution, amphibians, I mean they can live in water and land at the same time. And later on, these creatures, amphibians, they live on the land. They fully live on the land. So from there, these creatures on the land will spread out, and finally, all down the line, the mammals were formed and human beings were formed. Homo sapiens was formed, right? And that was one part of it, how mammals were formed, human beings were formed, right? From the non-living material in the ocean, organic material formed, DNA was formed, simple cells were formed, and then complex organic, what they call life form was formed. But then at the same time, another thing called the plants. So again, from the sea, the life went to the land, and then the plants formed, the grasses formed, and then the plants kingdom also spread all over the world. Now that was the earlier theory. So Professor Fred Hoyle and Chandra Wickramasinghe said, no, it may not even be long enough for life to occur. Life actually came from space. And one of the ways the life that comes from space is this thing called panspermia. That means you have a comet passing in the solar system. So as the Earth passed by the previous orbit of the comet, so all the debris will fall into the Earth as what? Meteor shower. And all those organic material in the meteor shower, or maybe the life, will drop onto the Earth and seed the Earth. And these two professors said, not only the life will seed, even life forms like bacteria, viruses, right, and other type of life form will fall from space onto the Earth. So in other words, not only one type of life, in fact, all life forms. That was their theory. So if the scientists are still doing research on it, so this research has not been proven or disproven yet. So scientists are still working on it. So if it's true, that means maybe even the virus that the whole world is now under the pandemic, the virus came from space also, right? So that's it. When you look at if you see a meteor shower with this, maybe you can connect with astronomy, all right? Maybe even the virus came from space. That's what the panspermia theory said from Professor Fred Hall and Wickramasinghe. This is still widely debated and research topic in astronomy, right? Any question? Yeah. Xinzhou, you are not on, huh? Another 40 minutes. Yeah. So as usual, our Astronomical Society of Penang has a lot of activities, right? So this is our online session twice a month. In the middle of the month, like this one, is our AstroCafe, right? Which you hold it in our Lim Chung Kiat Observatory in Balik Pulau, right? And also in conjunction with the peak of the meteor shower. And at the end of the month, we have the airport session, right? Astronomy picture of the day by NASA, the session, all right? So we are still waiting for the sky. So you see here, you see that the roof of the observatory is still closed, all right? Because there, yeah, because still quite cloudy outside. No rain, but cloudy. Yeah. So many people in the world, the most trustworthy source for any meteor shower is the IMO.net, International Meteor Organization.net. Net means network. IMO.net. So you go there, you look at the 2020 IMO.net meteor shower calendar, right? So according to the IMO.net, the Perseid Meteor Shower will peak tonight Malaysian time, 9 p.m. to 12 midnight. Right now, right? The actual peak is between 9 p.m. Malaysian time tonight and midnight, 12th of August, right? 3-hour peak. But we know that the Perseid Meteor Shower has a broad peak, right? So it starts in 17th of July and ends in 24th of August, a broad peak. Whereas the other meteor showers like Leonis, Gemini, it's a very narrow peak. Very narrow peak. So you miss the peak of the Gemini meteor on the 13th of December. You want to see 1 week later, 20th of December, forget it. No more already. But the meteor shower for this person is very broad. Right? You can still observe it until the 24th of August. All right. Another 12 days later, you can still see, but of course, not so many per hour. So according to the IMO.net, the maximum for tonight around the world should be about 110, all right, the ZHR, zenithal hourly rate. What I mean by that, zenithal hourly rate means tonight, imagine we are at somewhere in the world where the sky is perfectly clear, and you look up the zenith, right, and dark, no moon, nothing, very dark. So under that condition, you should be able to see tonight, anywhere in the world, every hour, 110 Perseid meteors. So you observe for 6 hours, you should see 660 meteors, or around 600 meteors for the whole night, right? But you know that the prediction for meteors are not 100% accurate. Sometimes you will underestimate or overestimate, right? So it can be more than 600 for 6 hours. You can see more than 1,000, right? So Perseid meteor showers we have been observing in Pulau Betong, Sukia's place for many years. We can see some years a few hundred, all right? Any question? Nothing. They're all still there. So now you all have your app, all right? You have your app here, your Sky Safari or SkyNet. So if you look at it, you on your GPS app location, you find that Perseus is still below the northeastern horizon. So for me, the northeastern horizon is over there, right? Still below the horizon. It will only appear at the horizon around midnight. So you still cannot see any Perseid meteor shower now. You have to wait until midnight. All right. So imagine now at midnight. So anyone who is watching is from Penang. So one of the best place to observe the meteor shower is what? Esplanade, Gurney Drive. Why? Because at Esplanade and Gurney Drive, you look across, it's the mainland, northeast. Remember, imagine you are at Gurney Drive or Esplanade, you look at Gunung Jerai, Kedah Peak. That's the northeastern direction. That's the direction, and at 12 o'clock, behind the mountain of Gunung Jerai, the meteors will start coming out, right? And the Perseid meteor shower are not very fast or very slow. They are medium speed. The reason is because of this. This is the sun. The Earth orbits the sun, all right, in a kind of elliptical orbit, and that's called the plane of the ecliptic. But when the Perseid meteor shower, the debris swarm, that means following the orbit of the comet swift turtle, they are not following the plane of the Earth's orbit around the sun. They are perpendicular. So if this is the plane of the Earth's orbit around the sun, the Perseid meteor shower will come at 90 degrees from the north. So sorry guys, you are from Australia, Chile, New Zealand, Tahiti, Fiji, cannot see, northern hemisphere. So we are lucky in Malaysia, we can see. So you come from the northern hemisphere, and the thing is, remember the Earth orbits the sun at 30 kilometers per second. And these particles from the comet swift turtle that causes the Perseid meteor coming in at 59 kilometers per second. But they're at 90 degrees. So eventually, the Earth's velocity doesn't count. So basically, when the meteor shower comes down and enter the Earth from the north, they will enter the Earth atmosphere at 59 kilometers per second. Quite fast also, all right? But if another case, let's say, imagine we are talking about the Leonid meteor shower. The Leonid meteor shower very fast. From one horizon to another horizon in less than 1 second. Why? Because the Leonid meteor shower this is the Earth moving around the sun in space, and the Leonid is coming at the sun in the early morning sky against it, they are hitting and colliding with the Earth. So in that case, the Earth's velocity and the meteor velocity is added on. That's why it's very fast. But for this case, this is our Earth's motion, and then the meteorite motion is like, no, meteor's motion like that, 90 degrees. So basically, they are coming into Earth's atmosphere to cause the Perseid meteors at 59 kilometers per second. Not too fast, not too slow. So if you have any friend around the world, can hear? If you have any friend around the world, please tell them to see. All right, you check on the weather map. But so now over Peninsular Malaysia, I don't know about Sabah and Sarawak. Over Peninsular Malaysia is still quite cloudy. So any question, Michael, you let me know. Any question?
Can you hear me?
I can hear you. I can see you.
Yeah. Maybe you can show them how to use the IMO.net, the calendar.
Okay, can also. I'll show them. Wait, I have to present now. Entire screen. Yeah. I show entire screen. Share, correct? How? How? Share doesn't share. Yeah. Share. Okay, can see, Okay. So now I open another window. We go IMO.net. So www.imo International Meteor Organization.net. Okay. Now this is what I don't follow the other website. This is the only website I follow for the meteor, because this is the gold standard for meteor shower. All right. You wait for it to come. This is maintained by a group of amateur astronomers. Okay. Oh, cannot be reached. Why? Reason why? Sorry? Why cannot be reached?
It could be your internet problem, I think.
No, but the Google Meet okay, what?
No, I'm not sure. Is it a website problem? What is the?
I don't think so. You see, see, I can check now again. Cannot. So, Michael, cannot. There's something wrong with the IMO.net website. Cannot go in.
Okay, never mind. Maybe I present.
Yeah. Okay. You present. You can go on the site IMO.net. You present. Let me see. I'll let you know where it is. IMO.net. So we are in a sense lucky. Why? Because near the what they call the equator, the only problem is the clouds and the mosquito. But here tonight don't have mosquito. Imagine you are observing in Europe, in Canada, USA, in Tokyo. Night can be quite cold. Although this is summertime, but at night can be quite chilly. So imagine you're observing in Mongolia, very cold, right? So that's it. So we are lucky in Malaysia because our weather not so extreme. So what we do is, the correct way to observe the meteorite is, the meteor shower is, just go outside as a group. No need telescope, no need binoculars. Lie on the ground on your deck chair, or just lie on the ground and look up and look at the for the meteors. Okay. Yes. I know that. No. Can you? I don't see a full screen.
Can see my screen?
I cannot see your full screen. I don't see a very narrow only the screen. I want to see your white screen. The IMO.net.
Can see now?
Now I don't see. Still don't see. You didn't present.
You didn't present.
No, you didn't present.
I don't know. I'm not sure what's wrong with that.
Wait, I check my IMO.net. Still cannot see. My one cannot. Cannot. You try yours and see. It can't be reached, my one.
Yeah, I don't know why I cannot share my screen.
You can see, So basically, if you go to the IMO.net, on the moment you open the first page, on the top left-hand corner, they say the shower calendar. When you go into the shower calendar, they are very detailed. January, the first meteor shower is, of course, in January is quadrantic meteor shower, right? From the ancient constellation of Quadrans Muralis. All right. So and then later you go month by month. You have each month we have a few meteor shower, usually at the minor one. And in August, you have the number 2 meteor shower for this year. this one, tonight's one, Perseid Meteor Shower. The bigger one is, of course, in December 13, Germany Meteor Shower. That is the bigger one. So are you able to present yet? Cannot, huh? Michael? You cannot. Yeah. Can you hear me, Michael? I continue. So imagine now it's about 9:30, another 2.5 hours before Perseus will rise in the northeastern horizon. So imagine you are now, let's say, imagine few of you, say place somewhere in Gurney Drive, facing the northern direction and looking towards Gunung Jerai, northeastern direction. And at midnight, hey, there's one coming. So remember, for many years in Penang, when we observed the meteor shower, when I was still in USM, I would advise the USM student, in the morning of the peak of shower, boys and girls, today don't talk, Tonight meteor shower, today don't talk. Can eat, can sleep, but don't talk. Why, sir? Save your energy for shouting tonight. Yeah, because once the meteor shower comes, or what comes, imagine you are a group of, say, 1,000 people look at 1,000, not many. You have up to 3,000 looking at a meteor shower in Penang. Say 1,000 people. The moment one bright meteor comes, imagine 1,000 people shout. If you are a very shy person, yeah. No.
Dr. Chong,
Yeah.
Wei Lun is here. Wei Lun say he can access our IMO, so he will present it.
Yeah, so Wei Lun, can you access the IMO.net and explain? I'll let you explain. Later I come back. Please, William, welcome our William. Our astrophotography Sifu from Klang Valley.
Actually, I can access, but then I think I also have a share screen problem.
Share screen problem. Okay. So what to do? I can see, because if you go to IMO.net, the first page, top left-hand corner, it says shower calendar 2020.
Okay, Dr. actually can share already.
No, when you share. I want to show the 2020 shower calendar. This is not the calendar. You go back to IMO.net, the first page, top left-hand corner, the shower calendar in English 2020. There, this one. Go. It's either English or in German. Can you go to, let me see, resources? Yeah. Okay, meteor shower calendar 2020. Okay, in English. Yes, English 2020. That's it. Thank you, William. Okay, so I am very sure the past few, we started in 17th of July, the past few weeks, people have been accessing this site like crazy, all right? Now, let it come. Is it PDF? Opening the file? Yeah. When you open the file, William, can you go to the Perseid? Still cannot open. Yeah. There you are. Can you make the screen bigger? Make the page bigger so you can read easier. Yes, thank you. So you see now, actually between 17th of July, August 24th, as I say, during 17th of July and 24th of August, the Earth would have moved through the space, orbit around the Sun, 120 million kilometers. That means this tube of dust that is following comet ship turtle, the diameter of the tube, not the length, the diameter of the tube is 120 kilometers long. Just a bit shorter than the distance between the Earth and the Sun, right? And this whole tube of dust is going all around the orbit of ship turtle. That means, remember, the perihelion closest to the Sun is just within the Earth's orbit, and what they call aphelion, the further from the Sun, is about the distance of Pluto from the Sun. So this ellipse is where you have this big tube of dust all around, and as the Earth enter into this tube, on the 17th of July, you have the first meteors coming in. So now, as you go into the center of the tube tonight, where the debris stream, the density is the thickest, right? So that's it. And then the maximum, of course, is August 12th, and it's 13 hours GMT, UT. to 16, actually 9 p.m. Malaysian time tonight, right now, until 12 midnight. All right. The other one, you leave out the note. You look at the zenith hourly rate, which I explained earlier, is very good, no? So in the past some years, the Perseid seems to be catching up. Previously, the Perseid was less. So now it's 110 meters per hour. Imagine you are in a desert, very dark sky, far from civilization. You should be able to see, if you have wide angle eyes, you can see more than 100 per hour. All right. And the radian is, of course, the alpha 48 degrees and the delta 58 degrees is the location in celestial coordinate. It's somewhere in the constellation of Perseus, and between Perseus and Camelopardalis. Camelopardalis is the constellation of the giraffe, right? And there's a drift also, drift. So William, can you move up this page? You show them the drift, radiant drift. Go to table 6. Stop. That's it. So you see, top left is Perseus, okay, and then you have and to the right of it is what they call Cassiopeia. That means on the 15th of July, the radiant comes from the small vertical tick, 15th of July. Then 25th of July. Then 5th of August. What does it mean? That means as the Earth orbits around the Sun between 15th of July to the 25th of August, the point which the radiant appear will drift in the sky. Why? Because remember, the Earth's orbit around the Sun is not a straight line, you know. It's a part of the ellipse, but the ellipse is not so elliptical. The eccentricity is very, very small. So basically, it's like a circle. So the Earth is actually turning in space, orbiting around. So as the Earth turns around the Sun between 15th of July and 25th of August, therefore looking at where the meteors are coming, so the meteors seem to come from a different part of the sky as the day passes, because the Earth is orbiting around the Sun in a curve. So that's why there's a drift, the drift of the radiant. You see quite a lot, you know. It drifts just below Cassiopeia, right across below Cassiopeia, approaching towards Perseus. So today is August the 12th. So you see, you saw August 05, August 15. At that point there, August 15 is a radiant. That's it. All right. Okay. So William, can you go up again to the earlier information again? Thank you. Good. Okay. Good. Okay, Ken. If you want to talk, you can you can talk also. So now you look at it. You see, the orbital period of the parent comet 109P Swift Turtle. I mentioned earlier what Swift Turtle, 2 American astronomers in the 19th century, they discovered it lah. So this is called what they call co-founder. Usually, sometimes the comet found by one single person, that bright comet like Chakotake named after one person. But this comet is named after 2 persons, right? 2 discovered around the same time, a few days difference. So they give. That means Swift Turtle comet was discovered in the 19th century. So that means already in 19th century, more than 150 years ago, looking for comet is already a challenge, a struggle, a competition already. People, because they don't have the IAU at that time, International Astronomical Union, in 1850. But already you can report it, and if you report it, discover that you are the first discoverer, you can give a name, you become famous. All right. So 109P is 109 for that year discovered. P means is a periodic comet, short period comet. All right. So periodic comet means that you come in, go out again, and come in again. All right. So this is periodic. So I think our Halley's comet with a period of 76 years will come under P. The previous one, the recent one, the new wise is a C. C means it's a long period comet, right? So a period, Neowise has a period of about, I think, 11,000 years. So it's a number followed by C. So that's the case. And then now you look somewhere on the 1, 2, 3, 4, 5, 6. Look at line number 6. A filament crossing has been recovered from the 2018 data, right? It occurred on August 12, around 20 hours universal time. Lambda not equal to 39.79 degrees at the predicted position. And you continue to read. Oh, now the meteor shower predictions are very accurate. The scientists have certain models where, remember, this big tube of debris that is in the orbit of comet Swift Turtle has a diameter of 120 million kilometers. Diameter, no, not the length of the tube. The length of the tube is the whole orbit of comet ship turtle. From the location of the Earth to the location of Pluto and come back like an ellipse. But the diameter of the tube is 120 million kilometers. So now the astronomers are able to find that in this big diameter, as the Earth crosses into the tube, certain parts of the tube, there are filaments, where the debris stream is thicker. So the debris stream is the filament. So that means they're able to find that from the previous what I call meteor shower observational data. They know that some parts of the tube, the density of the debris is thicker as compared to others. And once they know it, they'll make a prediction for the next return. So next return maybe next year, 2021, and the other years in future. They will say that now we discover this filament. So in the future years, the filament also can be seen. So now the meteor shower predictions are very accurate, right? Sometimes some of the meteor showers, the tube has 2 or 3 filaments, separated by about 2 or 3 hours, 4 or 5 hours. And sure enough, what the predictions say, now you see, wow, a lot. Then 1 hour later, less a bit. Then 2 hours later, a lot. According to prediction. And there are certain models for it. They're accurate now, right? Yeah. So can you move up a bit, William, the last quarter moon? Okay, the last quarter moon on August 11, last night, all right? So last quarter is our third quarter, which means that, we have a problem. That means the moon will rise in the sky in Malaysia after midnight. So just when the Perseid can be seen in the northeast after at midnight coming up, the moon is coming out soon. And the third quarter moon still is quite bright, all right? So remember, anywhere in the world where you have light pollution, the street light outside your house door, all right? Or then you have this moon, it will reduce the number of dimmer meteors that you can see. So you have very light polluted area, only the very bright meteors you can see, and the very bright star you can see. The dim meteors and the dim stars you cannot see. So, but here you have the moon. So it's 12th of August tonight. So after midnight, you have the moon coming out. So one way to solve this problem is don't look for meteors close to the moon. Look for the meteors in a direction away from the moon. Right? So imagine now. Now it's about 10 p.m. Malaysian time. So another 2 hours from now. Imagine now it's 12 midnight. The night of 12 August, 13 August, 12 midnight. If you are in Penang, you go to Gurney Drive or this Esplanade, you look at the Gunung Jelai, Kera Peak. There's the northeast. If you are in KL, let's say you are in the KL city center, you have to look at the direction of Ampang, northeastern direction Ampang. So somewhere above there, if the meteors come, okay, then let's say in Penang now, from the Gunung Jelai, you see the meteors come. So at midnight, if the sky is clear, you can see that's a good time to see. You know why? Because the meteors are entering our what do you call this Earth atmosphere at the grazing angle. In other words, imagine this is the Earth atmosphere. The meteors are passing right from eastern to western horizon, right across. So the meteors will be right throughout the whole sky. You can see, right from the northeast to the southwest. You can see, right? And it's a fireball, right across the sky from northeast to southwest. So that is at 12 midnight. So 1 a.m. about the same. They will enter the Earth's atmosphere at the northeast, right across the sky. But as progressively, 1 a.m., 2 a.m., 3 a.m., 4 a.m., and the sky is actually immediately shifted. So now you are, let's say, at 3 a.m. Or 3 a.m., the Perseid constellation no more at the horizon, it will be vertically overhead. So at that time, you still see a lot of meteors, but you don't see the meteors that fly across the sky. Now remember, at 12 midnight, you see a bright meteor right across the sky, east to west. It's called an Earth grazer. Earth grazer means it cut right across the Earth from east one horizon to each opposite horizon. So called Earth grazer meteor. Right? But now 3 a.m. Perseus is on top. So now you see that the meteors are coming. They're very short now, all over. So don't only look at the northeastern sky. You look all over. Hopefully not too near to the moon. Then you see the meteors are flying everywhere. And of course, we know now. If you work backwards, imagine you take a picture or video, you work backwards. When you work backwards, you always go back to that radiant point in Perseus constellation. Right, that's it. So then let's say you continue until 5 a.m. when the Perseid is close to the southwestern horizon. Then now again you see another type of Earth grazer, but this is from the southwest. The meteor, wow, right across the sky to the northeast, and so on. So you have two chances to see the Earth grazer. All right, 12 midnight, 6 p.m. 6 a.m. 12 midnight is they come from the northeast. They shoot through the sky in one stretch, right? And so it can go right from one horizon to another. Another one is at 6 a.m. tomorrow morning, if the sky is clear. Now we come from the southwest, right across the sky to the northeast or over the sky, right? So that's it. Now, let's say at 3 a.m. now, the point, the region is vertically overhead. They are very short, so don't get the wrong idea, If you look at, if you imagine at 3 a.m., I've seen it before. Why are the meteors so short? They are short not because that they are very short. They actually enter into the Earth surface more or less perpendicularly. So when they burn in the Earth's atmosphere perpendicularly, and right below the tip of it, when you see it, of course, you look at it like an angle. So it's very short. Whereas at 12 midnight, the meteor is an Earth grazer. That's why it cut right across the horizon, or eastern, one horizon to another. But when it's at the zenith, the meteor trails are still very long. That they approach you, so they look like short. But I tried to look at it with my naked eye. So far, I've not succeeded. And even in the long exposure photography, I've not seen it. I mean, you see a meteor coming, but it's like a point. I mean, the meteor is coming to hit in the Earth's atmosphere, perpendicular to the Earth's surface, and coming towards you directly at your eye, so you don't see any left and right, up and down motion in the meteor. So this is very rare. I've never seen it before. Right? Usually, I can see towards the right or left of my eye, short meteor, but short in my mind. But I know that the meteor passes through the whole Earth atmosphere. Remember, Earth atmosphere is 100 kilometers thick. So actually, it will pass through it. But it's not true that you see a meteor. Let's say you imagine, many times you have seen a meteor shower, and people will make a call to me the next morning. Dr. Shaw, last night, I saw a bright fireball, that the meteor shower. I said, so I said, how do you find it? It just flew above my house. I said, cannot be. Do you know that the meteors are particles of ice and dust that came up from the comet or asteroid? They enter the Earth's atmosphere at 100 kilometers from the Earth's surface. By the time they reach 80 kilometers from the surface of the Earth's surface, already burnt out. Very few meteors will go closer than 50 kilometers to the Earth. No, by 50 kilometers, already all burnt out. So basically, you see a bright meteor is either 50 kilometers from your house, high, or 100 kilometers up from the house. So very high up, So imagine you see a very dim meteor, but by right, it's very bright because it's so high up. If you're very near, imagine you're Superman, you go close to the meteor shower, very dim one, you'll be very bright, right? And we know that each meteor they come in, the scientists have made a calculation. The diameter of the tube of the meteor is about 1 meter, or 1 meter, but the length of the trail can be 10, 20, 30, 40, 50 kilometers long. So it can be up to 50 kilometers long or 10 kilometers long. So the diameter of the meteor tube is 1 meter only, right? But what about your fireball? You see, where fireball? So some people call me and they say, I saw the fireball above my house. I said, no, it's actually above from the house 80 kilometers. Wow! That means from Penang until where? Until this Sungai Petani, right? Or from KL to Seremban. So imagine you have a fireball that is 80 kilometers from the Earth's surface in the Earth's atmosphere, and you are Superman. You go up to 80 kilometers high, close to the meteor trail, and come next to you. Wow! It will make you blind. So any bright meteor or dim meteor is actually very bright because so high, so far up, high up. Okay, so like this. So I think this is about all here, right? Okay, this one, of course, most people can understand. What causes the flash in the meteor? That we know. Remember, the debris stream of the comet swift turtle is orbiting around the sun at about where it is now, 59, say 60 kilometers per second. per second. All right. So when this, imagine a particle of dust from this comet sweep enter the Earth's atmosphere. So basically, it enter very fast. Also, it's called what they call resistive heating. All right. So as this particle enter the Earth's atmosphere, so the front part of the particle that entering the Earth's atmosphere is under compression, and there's high compression. When you compress the air and friction the air, heat it up. It can be heated up to, the scientists are so accurate now. They say that the front part of the meteor, of the particle enter the Earth's atmosphere, can be heated up to 1,250 degrees Celsius. Hot, oh, very hot. All right. So this is very hot. That's why I give a flash. All right. But behind the particle is what? So remember, the particle is pushing, going in front. So in front, the air is compressed and friction very hot, 1,250 degrees Celsius. Behind is a vacuum. Vacuum, you know. So because of the fact that in front is high pressure, compressed air, behind it is practically a vacuum. So there's a difference in the pressure, front part of the particle back. It will crush and break up this particle. Even if this particle is a meteorite, that's how the meteorite break up. Now imagine I have a 1 centimeter piece of stony iron meteorite, right? That came originally from an asteroid. Enter this atmosphere at very fast speed. So the front part is friction, all right, compression, very hot, and the back part is vacuum, big difference in the pressure, and if the meteorite got holes in it, porous, so this air in front compressed will push through the tubes in the stony iron meteorite, go behind, and because front is high pressure, back is a vacuum, and push through, it break it up. So that's what makes it break up, right? And again, if the meteorite were to fall on the Earth and break up, it will not fall like some people imagine. No, I saw the meteorite fell behind my garden in my house. Yes, it cannot be. Again, the meteorite will be broken up very high up, 50 kilometers and above, high up. I don't know, in 2013, the famous Chelyabinsk meteor that entered the Earth's atmosphere and broke up over Chelyabinsk in southern Russia, right? Might be very high, all right? But this is not like Chelyabinsk. Chelyabinsk is actually solid material, maybe from asteroid, but this one is the particles, ice and the dust particle from comet sweep turtle. And remember, comet sweep turtle is 26 kilometers in diameter. Other than the moon, this comet is the second largest object that comes close to the Earth. The other objects, of course, got big asteroid, hundreds of kilometers or thousands of kilometers, but they are in the asteroid belt, will not come close to the Earth. But other than the moon, this the nucleus of this comet sweep turtle is the second biggest object after the moon to come close to the Earth. Of course, there were the earlier apparition of this comet sweep turtle in the 19th century, and also they recovered in the 20th century. The first calculation was the year 2026, comet sweep turtle will crash into the Earth. They were so scared. Then they have subsequent further observation. Then they realized that comet sweep turtle will not hit the Earth in the next 2,000 years. Only 2,000 years from now, and after that, we don't know whether it will crash to the Earth. Why? Because as these comets and asteroids, they come into the inner solar system, go around the sun, and go back, because they are in highly elliptical orbit, go up, back, and come again. The orbits are not 100% you can calculate. For example, you have a planet, say like let's say like Mars orbiting around the sun. Remember, Mars only have a thin atmosphere, so Mars just considered as a solid body. So as Mars orbit around the sun, the only force affecting the orbit of the Mars orbiting the sun is only the gravity between Mars and the sun. That's all. But what about comet? Comet different. As the comet comes in and out, the comet will give off jets, jets. Why? Because the sun's solar wind and the sunlight will fall onto the frozen material of the comet nucleus and evaporate it, and it will blow it to cause the tail, the two tails or the three tails. So this tail will create the jets, and these tails are what? Non-gravitational effect. So you want to simulate the orbit of the comet around the sun. You just say, okay, it has 26 kilometers in diameter, so much mass. I can simulate it due to sun's gravity on the comet. You're wrong. You cannot, because they are jets shooting up, and these jets are forces that will perturb, will add on or to subtract from the sun's gravity on the comet. So these are the non-gravitational effect, and the non-gravitational effect will affect the subsequent orbit coming back to the inner solar system significantly. So that's why the orbits of comet, once it comes back and out, you cannot predict it accurately. For example, you look at comet Neowise, have you observed or not? The comet Neowise, the incoming orbit, that means half the orbit, the incoming orbit, the time is 4,500 years. The outgoing orbit now is going out from the solar system. Comet Neowise is 6,500 years. How come? By right, the incoming orbit, half the orbit is so many years. The outgoing orbit should be the same number of years. Just like if Earth goes around the sun in half the orbit, half a year. The other half of the orbit will also be half a year. But Neowise is different. Coming in 4,500 years, going out 6,500 years longer. Why? Because when the comet comes in and out, all these non-gravitational effect due to the jet shooting up will change the orbit, will affect the gravity of the sun on the comet. So that's why it's different. Coming in 4,500 years, going out 6,500 years. That's it. All right. So that's it. So so now we know that. Of course, another one even more important, but I didn't see any announcement on this. Maybe I should look at the research paper. Any comet, long period comet, Halley's comet, whatever comet, that comes in from say from the location of Jupiter, Saturn, and Pluto, and even further close to the sun, come in the solar system and go out. Jupiter's location is important because Jupiter's gravity is very strong. So if the incoming comet comes inside this time and when near to the sun, but quite close to it is what Jupiter. Now Jupiter has a big mass, strong gravity. So the Jupiter's gravity will affect the orbit of the comet tremendously. So by coming in, the comet orbit is affected a lot. So when it comes in, it doesn't follow the earlier predicted orbit. Now Jupiter is there affecting. So it comes in is different change orbit. So when it go out of the solar system, the future orbit will be different because of Jupiter. Or it comes in that time, Jupiter is not nearby, far away, no effect. Now the comet orbit the sun and go out of the solar system. And going out of the solar system, you have Jupiter nearby. Now Jupiter will affect the orbit of the comet. So this effect on the orbit of the comet because of Jupiter. So the subsequent return of the comet will be totally different. So everything, so when it comes into the ordinary solar system, Jupiter followed by Saturn, because Saturn has got a big body. So Jupiter and Saturn can affect the subsequent orbit of any comet. So that's it.
About the time.
Yeah, about the time. So okay. So William, you want to continue? Michael, I just can make a few more closing comments. Okay. So okay. So now the weather is our Mr. Chai told me that it's about time. So now we still hope the weather is clear. Right? Weather is clear. And then I am very sure now, right now, 10 p.m. Malaysian time. Where now the Perseus has risen? Hawaii, Tahiti, Fiji. Maybe you are somewhere in eastern Siberia. Can see already. And if any amateur astronomers there, they are shouting. What about Africa? Cannot. Africa is in daytime. Europe cannot. America just entering the morning sky, so cannot. So it's actually now the first people in the world can see it in the Pacific Ocean. All right, Hawaii, Fiji, Tahiti, Easter Island, just west of South America. All right, these are the places. So if you have any friends in these places, Tahiti, Hawaii, please inform them. Well, maybe the sky is good. All right. So Michael, do you want to continue or we end now?
I informed him.
Okay, okay, we end now. Okay, thanks a lot for your attention. All right. So we will announce a future activities in future. And thank you very much, William. Thank you, William. Okay, William, thank you.